DRA Global is a leading international engineering, project delivery and operations management group with an impressive track record spanning more than 3 decades. DRA Global's team of experts drive innovation through world-class consulting services and support clients across multiple sectors to achieve their goals in minerals and metals processing, mining, infrastructure, energy, water, industrial, operations, maintenance and shutdown services.
Good afternoon and welcome to our live session on Continental's sensor-based drone inspection service, a smart technology that was developed by Continental Conveying Solutions. Conveyor belts are widely used for industrial purposes to transport different goods involving tight curves and steep inclines. The early identification of defects of conveyor belt systems can be of crucial benefit for operators to prevent them from unnecessary downtimes and delays. To make this early detection of weaknesses easier, Continental has developed a remote inspection service for conveyor belt systems that includes a drone on the one hand and an artificial intelligence system on the other. Sounds interesting to you? I agree. So let's give a warm welcome to our Continental expert of today's session. But before I say his name, an important note: we all were tested negative for COVID in the morning, so all of us are safe. And now here is the name and the face of our expert. It is Clemens Panzer. Thanks for being with us.
Hi, Alyosha. Good afternoon.
Clemens, as the project lead for autonomous drone inspection of conveyor systems, you are responsible for the development of remote inspection service from concept to product. To be honest, I'm not really an expert on conveyor belt systems. So please tell us, what was the reason you developed such a solution?
Well, imagine for a moment being the maintenance manager of a mine site. And in your position, you're responsible for the condition of all the equipment and machinery, and amongst others, as well for the conveyor belt systems. Now, such a mine site can easily have up to 40 kilometers of conveyor belts, and that sums up in total over 250,000 rotating components, which are carrying the belts, the so-called idlers. Now, failures of those idlers can actually occur at any position along the conveyor belt system. And the reason for that is because they have millions of rotations over their lifetime, and they just simply wearing down and tend to fail there a lot. Our research has shown that over 30% of the operational downtimes of conveyor belt systems can be traced back to idler failures that got not identified in time. So why is it so hard to identify such an idler failure in time? The reasons for that is quite easy to understand if you know the current process of doing that. The current process of inspecting conveyor belts is a highly manual process. So entire maintenance crews and technicians are walking there all day long along those conveyor belts, trying to spot those failing idlers. And once they have spotted one, they are actually in the reactive position. So they can report that in a paper-based report. And based upon that report, you can actually then plan your maintenance activity. Or if it's already too late and you immediately need to change this idler, you just shut down the belt immediately and you go there and change it. And in my opinion, that's not a really smart process. So that kept us thinking, how actually can we automate that process and how can we support it by using modern technologies such as drones on the one hand, and on the other hand, modern software solutions to support that process and to digitize it so that actually you can put with that solution the customer in a proactive position, having really the data at hand and planning on that data upfront, the maintenance windows that are necessary to put that back into a good condition.
To get a real feeling, you brought several videos with you to the studio. So let's have a look. And please tell us what the drone is doing there.
Absolutely. So the first step of our solution is the collection of the data, and therefore we are using the drones. And as you can see here, the drones are flying in pre-programmed flight routines that we set up in alignment with our customers. Here's an example of such a flight at a small scale. And the drone that we're using there is equipped with a dual camera system, means a daylight camera, as well as an infrared, or as well you can say thermal camera. And at the same time, when taking pictures along that conveyor, we are as well tracking the GPS coordinates, so the position of that flight along the conveyor, and we add that to our records. Now, in the next video that I've brought with me, you can see actually what we just have seen in the recent video, but from the perspective of the drone. So you can see there that was shot from roughly 5 to 10 meters away from the conveyor, and you can see how we are actually capturing those objects of interest, the idlers, and in what quality we can actually capture them in order to potentially in future then try to identify a failure in that pictures. At the same time, I've brought a third video, which is now we basically switch the perspective. We are still in the perspective of the drone, but now looking through the eyes of the thermal camera. And if you have there a closer look into this video, you can probably already spot some hotspots, some potential failing components. And the reason why we see there this increased temperature is because if an idler is failing, it will always create friction because something is not really working well anymore, and you create friction, leads to heat, and in the end that leads to a failing idler. Now, whenever we spot such a hotspot, that's exactly what we are going to save then from our data, and that is what we are providing then in our third step of the solution to our customers in the customer portal.
So the drone is set up with cameras, and the cameras are responsible for collecting the data. But what happens next? How does the data transmission work, and what about the access for the operator?
Well, as I have said, the first step is the drone collects, and the cameras of the drone collect the data for us. And you can see that here in this animation again. The drone is doing the job in a remote and autonomous mission, and once this drone mission is completed, basically, and the batteries of the drone need to be recharged, it just simply flies back to its drone shelter, the home basis of the drone, and it recharges the batteries. And while doing that, we can actually use that time to upload the data that we have collected in that recent flight to our cloud system. Now, in the cloud system, our software solution picks up the data and starts to analyze it. And we analyze that data and that locations of the videos by using an artificial intelligence. And if there's a hotspot observed, as I said earlier, we save that information, and we can later on show that in our portal to our customers. And with that portal, the customer can interact with the data.
So as I understood, there is an AI algorithm for the collected data. But what exactly is the AI algorithm doing?
Well, to explain that, probably you have seen in the past or in your daily life actually some other applications where object detection algorithms are used. For instance, sometimes you see those bounding boxes when they identify or try to identify a dog or a car or any other object that you basically train the algorithm upon. And we do something very similar in our approach. We just identify idlers. Now, if our artificial intelligence algorithm identifies such an idler or even a bunch of idlers in a picture, it starts looking into those exact locations where the bounding box is drawn and where we have identified an idler, and we try to identify there a potential failure. And now comes the infrared picture into the game, because there we can see in those locations, we can analyze the temperatures, and we can see, is there an anomaly, is there a hotspot, or any sign for a potential failure of an idler. If that's the case, we save that together with the GPS coordinates and with other information that we get from our analysis, and we can show all of that, 2 pictures, the location, what is happening, and how critical it actually is in our customer portal.
Clemens, is it possible to get a sneak preview of the software? And please say yes now and no is not acceptable.
Yes, definitely. I can walk you a bit through that solution.
Thanks.
So let's assume for a moment we have now finished the drone mission, right? As you have just seen in in the video. And now you're interested in seeing those results out of the inspection. So you use there the customer portal, you log in, and the first thing that you're getting to is actually the company site level. On the company site level, you can see, first of all, in your company site header, some information about what mine site are we talking about. You have then, just below that, as the first object in our software, the company site dashboard. And that dashboard basically gives you, in a first glimpse, already an overview, how are my conveyors behaving in terms of the condition of the idlers. So you see there how many are in a critical state, how many probably in a poor state, but not yet too critical, and how many are in a good state, and I don't have to do anything about them. Now, as the maintenance manager, again, you would be interested in having more information about one specific conveyor. So for that reason, we have there our conveyor list, which lists basically all the conveyors of your mine site and is sorted by the criticality of the findings that we have seen in our drone inspection service. As you see here on the first row of the list, there's the conveyor 23, which apparently has the biggest problem, and the state is really in a critical one, shown by this traffic light indicator. You see some information about the length and when was the last time you actually inspected that with a drone. And if you now want to really even have more information about that conveyor, you can click there and you land on the next page, which is now the conveyor 23 level page, basically. There you can confirm again, okay, we are looking at the exact conveyor that I want to look at by clicking there into the picture of the conveyor. And you have some information about how long the conveyor is. In that case, almost 3.5 kilometers of length, and quite a lot of idlers actually in that conveyor. Again, same logic as before, but now specifically for that conveyor, you have there this overview about the condition of my idlers in a gauge chart, it's called, where you can really easily see on one hand, okay, this is the exact criticality of my conveyor. Now, you have seen before in the videos, we spotted there some hotspots. And actually, I said we saved there those hotspots as an information, as a finding. In our customer portal, we show that to the customers. So if you want to do that, you go to the conveyor inspection details. And as you see here, we first of all start on the kilometer level. There, remember, it is a 3.5 kilometer long belt. And apparently in the first kilometer there's a problem identified. So I would go there and I actually get directed to the first kilometer of my belt. Section-wise, we separate that into 100-meter sections. Now, still not a very good precision in terms of getting to the pain point and actually changing that idler. So we drill down further down in our levels until we realize, okay, between 30 and 40 meters, there's actually the findings that we have spotted. And by clicking one more time, you actually get there to the pictures level, where you can see now, okay, we have 3 findings. You can open one of them if you want to have a closer look into what got actually detected in the infrared picture. At the same time, you can see from the same shot the RGB picture to understand which of those idlers is the exact problem. And we have the map functionality, which actually leads you now, if you have your smartphone at hand, leads you to the exact position where this picture was taken from. And you can actually change that idler immediately if you have one at hand. If you do that now, and that's actually what you want to do as a maintenance manager because you want to put all the conveyors back into a good condition, you change that, and now interactively you can say, hey, I got that fixed. So I click there in my system, and actually what happens now is we process this request, and once this is processed, that finding is appearing as a good finding again. So somehow like that, you can document already what you have done in terms of maintenance to your conveyors, and step by step clean up your system and bring all the conveyors back into a good condition.
Awesome. But how does this software technology fit to the existing portfolio from Continental? And are there any other smart solutions like that to keep conveyor belt systems safe?
Well, as Continental, we are a provider of solutions, right? So that means we do not only plan, build, and install conveyor belts anymore, but rather we monitor them again as well. So that means, as you have just seen in the drone inspection service, that is only one puzzle piece of our portfolio. So we have there a broad conveyor monitoring portfolio, which we call the Conti Protect series. And all of those systems in there, which is all sensor-based and fixed installations that you can buy and install on your conveyors, all of them have the same goals. And those goals are to make conveyor belts safer on the one hand. The second one is to create better knowledge about the condition and to know when you need to plan your maintenance accordingly. And the third is to understand better the efficiency of your material process handling process. So basically like that, you know from our systems, hey, how good am I using my belt? How good is the overall capacity that I'm using from my belt? And can I improve there probably? Now, if you're only interested in having such information and such details of information about your conveyors from time to time, that's no problem. We can offer that as well. That series is called the Conti Inspect series. It's basically the same technologies that we use there, but we offer them on the fly. So basically our trained Continental personnel can come to your site, can conduct those measurements, and in the end they generate the reports out of those measurements and can provide that information to you. Now, to make that picture complete, actually, and if there's still the need for actively maintaining and doing the dirty work, let's say, on site, we can actually offer that as well with our globally network of Continental service technicians. And with that, as I said in the beginning, we see us as a whole solution provider.
So in a nutshell, you're offering a 360-degree solutions approach. That's great. Is it, by the way, true, in German we call it Buschfunk, yeah? That Continental has an internal incubator that supports projects like this?
Absolutely, you have heard that right. So when we had the idea initially, Continental gave us the chance to bring that into our internal incubator. And Conti gave us there the chance to deep dive into this idea for a dedicated time of 12 weeks in a cool co-working environment in the middle of Berlin. And we brought there together a small team of experts. We were 3 persons. One was a mechanical engineer with the background in the conveying solutions industry. We had a data scientist that had broad experience in handling large data sets and knowing how to get the best results out of such data sets. And third, but not least, we had a computer vision engineer who was able to actually create, in a very short time, a first demonstrator of what we had in mind as a software solution. And that broad skill set and diversity in the team was actually the key and was creating the speed there to come up with a technically feasible and from a business perspective viable concept that we were able to demonstrate then to the management, and we actually convinced them to make out of that concept a real project in our business, and now it's actually leading to a real product, and that's really awesome to see.
Perfect. So, Clemens, we are almost at the end. For the big finale, I have 2 more questions for you. First, is the development already finished? And the second question is it already possible to use the Continental remote inspection?
So, as of today, the solution has successfully tested in several field trials. And the software solution is as well almost ready and completed. So the first data collections, as you have seen in the video, have taken place. And now we actually plan to do that at large scale. So we are actively looking there for pilot projects with customers where we can improve certain things of our solution and we can really test that with larger data sets. And the final goal is there to have an operational service that we can offer to the market in the course of 2021. And to your second question, so if there's a customer or someone from the audience that really caught now the attention here and is really interested in learning more about that, you can always feel free to contact us through the known sales channels or the regional contacts that you have from Continental. And I'm absolutely sure you will be directed to the right address to get more information about that service.
Perfect, Clemens. Thank you so much for being with us. I'm a big fan of your technology, so thanks again, and I hope to see you soon again.
Thank you.
DRA Global is a leading international engineering, project delivery and operations management group with an impressive track record spanning more than 3 decades. DRA Global's team of experts drive innovation through world-class consulting services and support clients across multiple sectors to achieve their goals in minerals and metals processing, mining, infrastructure, energy, water, industrial, operations, maintenance and shutdown services.